Dear students, today we discuss about Hartley oscillator. Hartley oscillator is a LC type oscillator. What is L? L is the inductor coil and C is the capacitor. The tank circuit of the Hartley oscillator consists of two inductor coils and single capacitor. The tank circuit is the main part of the Hartley oscillator which produces the damped sine wave. Here, a small introduction about Hartley oscillator. This Hartley oscillator is invented by the American engineer Ralph Hartley in the year 1915. This, you know well that the oscillator generally consists of a main part as a tank circuit, uh, and a amplifier and a feedback network. Tank circuit, amplifier, feedback network. Here, in the Hartley oscillator also consists of a tank circuit. The tank circuit consists made up with two inductor coils and single capacitor. The inductor coil and the capacitors are connected. The two inductors are connected in series and the inductor and capacitor are connected in parallel. Now we see about the construction of Hartley oscillator. The Hartley oscillator mainly consists of a tank circuit, an amplifier and a feedback network. In this amplifier section, the main active component is transistor, and the transistor is a NPN transistor. It consists of a emitter resistor Re and emitter capacitor Ce connected to the emitter of the transistor Q1. The emitter is always be given forward bias as it is a n-type material. So, a negative potential is given through the resistor Re to the emitter of the transistor, and the base is always be given forward bias as it is NPN transistor. The base is made up of p-type material. A positive voltage is given using the source plus VCC and the potential divider resistors R1 and R2. Depending upon the values of the resistor R1 and R2, the DC voltage, the whole DC voltage plus VCC is altered and a part of the DC voltage is given to the base of the transistor. And the collector of the transistor Q1 is biased using the resistor R4. The collector is always be given a reverse bias. So, it is NPN, so the n-type material. So, the positive voltage is given to the collector of the transistor through the resistor R4. We already know that Cin is the blocking capacitor which blocks the DC voltage from the biasing voltage source to pass through this capacitor. Actually, it blocks the DC voltage. Okay. This capacitor is also used to block the DC component. It allows only the AC component and also used to connect the amplifier the feedback network, and the tank circuit. The another most important section of this Hartley oscillator is tank circuit. You know well that the LC oscillator's tank circuit consists of a inductor coil and a capacitor. In Hartley oscillator, the tank circuit consists of two inductor coils, L1 and L2, connected in series. The two ends of the inductor coil is grounded here, and the capacitor is connected parallel with these two inductors. So this tank circuit produces the damped oscillations. How they are producing oscillations? Already we know that it is a basic circuit of a tank circuit of LC oscillators, which consists of a inductor coil and a capacitor and a battery, DC battery. Here the inductor coil and the capacitor is connected in parallel. Initially, the DC voltage is passed through this line when the key is closed here at A. So the DC voltage, a positive DC voltage, is passing through this wire and here, and then it goes to the capacitor. So the capacitor charges the plus here, minus here. So the capacitor charges fully using this DC voltage. After charging, the key is transferred from A to B. Now the voltage in the capacitor starts to discharge through this key, and the positive voltage comes here. This DC positive voltage is passing through the coil. When the current is passing through a inductor coil, the coil produces the magnetic field around this, like this. It produces this according to the Faraday's law. When the current is passing through a inductor coil, the inductor coil produces the magnetic field. So this current produces the magnetic field. When the capacitor starts to discharge at a particular time, the voltage in the capacitor becomes 0. So there is no more voltage to supply the coil. So the magnetic field produced in this coil starts to decrease. This is equivalent to a coil cuts the magnetic lines of force, or a magnet is passing through the coil. When the coil cuts the magnetic lines of force, a induced EMF is produced in this coil. The induced EMF produced in the coil is in the opposite direction to the current responsible to produce the magnetic field. So initially a positive voltage came here, negative voltage came here. It produces the magnetic field. Again, after the shrinking of magnetic field, it produces a induced EMF with negative sign. So the negative voltage, negative induced EMF is produced here. Here positive induced EMF is produced here. So this negative voltage again goes here and charges the capacitor. This negative voltage goes there and charges the capacitor. This positive voltage goes there and charges the capacitor. So, the capacitor charges due to this EMF produced in this induced coil. When the capacitor charges maximum, again it starts to discharge. So, here minus, here plus. So, a negative voltage is again came here. This negative voltage is again came here, and the positive voltage is appears here. Again it produces the magnetic field. Again the magnetic field starts to shrink, start to reduce. During the shrinkage of magnetic field, again it produces the induced EMF with the opposite side. So from negative to positive. Again this positive voltage charges the capacitor. Again it gets maximum. Again it starts to discharge. So this process repeats. Once when the process are happening, due to the reactance, the resistance produced in the capacitor and the resistance of the inductance coil, the charging voltage and discharging voltage goes on decreasing. Due to this reason, initially it gives the wave with maximum amplitude, and then the amplitude of the wave goes on decreasing. This is known as damped wave. So this inductor coil, capacitor and the DC voltage produce damped wave. Okay. But we need a undamped wave in its output. So the part of the output, the part of the damped wave from the tank circuit is taken back. The voltage, the wave across the inductance coil L2 is again fed back to the amplifier. So a part of the damped wave from the inductance coil L2 is taken and again fed to the input of the amplifier. This amplifier amplifies the amplitude by combining this AC signal with a DC part. Both the AC and DC part combines here. Totally it is a DC voltage. It is passing through the base of the transistor. This transistor amplifies and gives the output here. So the output consists of a DC level and a amplified output wave. Here the amplitude of the sine wave is constant. So this capacitor blocks the DC level and allows only the amplified constant amplitude output here. When the power supply is switched on in the circuit, the transistor starts to conduct and the collector current increases. As a result of the capacitor, C1 start discharging. Initially, it is charging using the DC power. When the capacitor C1 is fully charged, it starts to discharging through the coil L1. This charging and discharging creates a series damped oscillation in the tank circuit, and it is the main part to generate damped wave as we have discussed. Okay. See this tank circuit produces the undamped wave. A part of the wave is taken here and again is given to the transistor. This is amplified. The amplified output is appear across the collector and emitter of the transistor. Okay. The voltage of the transistor will be in phase with the voltage, this voltage. the voltage across the inductor L1 and the output voltage both are in phase, since the junction of the two inductors are grounded here. But the waveform and the voltage across the L2 is 180 degree out of phase with the output. See here, the voltage across the inductance coil L2 is 180 degree out of phase to that of the voltage and this voltage. So, the voltage across the L2 with 180 degree phase shift is given here. This transistor amplifies, again it inverts 180 degree phase and gives a total of 0 degree or 360 degree shift in phase. So here a 180 degree, and this transistor alters the 180 degree phase. So this inductor coil alters 180 degree, and the transistor again shifts the 180 degree. So totally the 360 degree phase is shifted, that is equal to 0 degree. So you will get the sine wave like this in its output. So the total phase difference between the input and output is 360 degree, and it will produce a sustained constant amplitude oscillations. Only are frequencies for which the gain around the feedback loop is 1, and the phase shift around the feedback loop is 360 degree or 0. So it follows the Barkhausen criterion. The frequency of the output wave is altered by changing the value of C1 or the value of L1 and L2. Generally, the value of capacitor is changes to get different frequency, constant amplitude output sine waves. The frequency of the oscillator is determined using the formula F is equal to 1 by 2 by root LC hertz. Here L is the value of the inductance of the inductor, and C is the capacitance of the capacitor present in the capacitor present in the tank circuit. So this oscillator, Hartley oscillator, is used to generate sine waves with constant amplitude.